All right, this is the page number that your notes are going to go on. But before we start on that, I just want y'all don't have to write this down anywhere, just stick with me here. If I said that f of x is equal to the integral of x plus 1 dx, okay? Is that something you can integrate? Yes, I hope so. That means I can get that f of x is equal to what? What does this give me? X squared over 2 plus x plus c. Very good. Okay, piece of cake, right? So we have that plus c because, remember, if we took the derivative of this, c is a constant, it just zeroes out. So there's not enough information in there to tell us what c would be. And that's why when we had those, the slope fields, it was kind of all over the place because you could shift it up and down, or, we didn't know really where it was. But what if I told you that f of 0 equals 5? Then could you, bless you, then could you figure out what c is? What would c have to be? Which one of these two numbers is my x value? 0. And so if I found f of 0, that's going to be 5, right? Because these are going to zero out. Yeah, that's how I get that. So c is equal to 5. Yes? That makes sense? Yes? Okay. So what if I said that instead f of 2 equals 5? Then I would say f of 2 would be equal to 2 squared over 2 plus 2 plus c equals 5? Yes? All right, so what's 2 squared over 2? 2, so 2 plus c equals 5. So what is c going to equal? 1. Okay? So depending on your initial condition, where'd I lose you? No, you good? Yeah, okay. I know, I'm doing the really difficult stuff for you up here. But depending on your initial condition, c can change, right? It gives you a different function. Well, this is basically what we're going to be doing, is actually getting some c's and getting, this is what's called a particular solution. So particular for a specific graph instead of generalized here. And so if we look here, so we have separable differential equations. And remember, differential equations just means these are equations that come from taking the derivative of something. It's just a derivative, that's all it is. Just a different way to say it. All right, so a differential equation in x and y is an equation that involves x and y and the derivatives of y, okay? Previously, we've solved two types of equations, those in this form here, right? We have solved those. Now we will learn to solve more general type of differential equations called a variables separable differential equation. Separable differential equations is another way to say it. So we're going to do a separation of variables so that we can actually go a little bit farther, okay? So a differential equation that is in the form, or that can be put in this form, dy dx equals something, and we have an x and a y, or maybe we just have one or the other because one of them could be 0, is separable. And then to separate variables, it tells you how to, like, this looks all weird because math things a lot of times do, and we have to use a ton of variables. So I'll just kind of talk you through it, and then I'll show you what's happening here. So the first thing we do is separate the differentials. The differentials is this part right here, the dy dx thing. That's what we're going to separate first. Then we worry about the rest. And we do the rest with multiplication and division. And then if there's a constant, the constant, if there is one, can stay on either side. However, if we try to solve the differential equation into the y equals f of x, which is usually the road that we're going down here, it's better to keep the constant on the dx side. Okay, so you could put it on either one, but it's just going to make it easier most of the time to leave it with dx. And I will kind of re-explain what that stuff means as we go through. Okay, but those are the key points of that. So let's look at this first one. We're going to separate the following differential equations if they are separable. So when we start here, the first thing we want to do is separate the differential here. So this is just a fraction, which means I can multiply both sides by dx. So this is going to give me dy equals negative 2y times dx. Okay, everybody good with that? No biggie? Now that negative 2, that's my constant. I'm going to leave it on the dx side. But now is when I have to get everything that's y with dy and everything that's x with dx. I don't have any x's, but here I can divide both sides by y, right? So if I divide both sides by y, dividing by y is the same as multiplying by what? 1 over y. So then this can become 1 over y dy equals negative 2 dx. And I have separated it. And I think most of the time you're not going to really, I mean, I could have left dy over y, but remember when y'all had that and you were integrating, then you got stuck, you're like, what the heck am I supposed to do with that? Like with the u, it's going to look much better to you and be better if we actually have it 1 over y type of thing. Okay, we good on that? All right, you try number 2. It's like some of y'all are making up math. A lot of you are making up math. You're going to make me cry. Y'all are all going to make me cry. Y'all are all doing the same thing. Y'all all need to go back to Algebra 1. Every single last one of you. Okay, here's what... Yeah, that's the first one I've seen that looks good. Here's what you can't do, which is what most of you did. You sad little people. All right, we did dy equals negative 2y plus 3 dx. I don't even know if there was parentheses there or not. And somehow we think we can magically divide both sides by y and our life is good? What, can we do that? Okay, but here's, well, yes. I mean, technically, when you do this, you should have parentheses here, right? And whether I distribute that dx or not, I still cannot just divide by y, right? Unless I divide every single term by y. Totally illegal. Yes, do we understand that now? Do we know better? Do we promise never to do that again? Do we promise to try to never do that again? Okay. All right, then all is forgiven. Now finish this. Don't make it harder than it is. Hamza, what can I do at this point? So I can divide both sides by this and get 1 over negative 2y plus 3 times dy equals dx. I think because I said, I'm hoping that this was part of the issue, because I said leave the constant with the dx if you can. You don't have to, and you can't in this situation, because if you try, like here, if I had distributed this, here, let me just do this over here. If I did dy equals negative 2y dx plus 3 dx, oh, a little too close to the edge there. That's maybe you trying to keep that, but then you can see I can't even here, I can't divide both sides by y, and if I move this over here, that moves the dx back over there. So you'd end up having to factor it back out, and you could end up back there anyway. So there's no way to do that, okay? Are you just sitting like that, or are you flipping me off? Because it's okay. Just checking. Yeah. Okay, that makes me feel better. I would appreciate that more. Okay. All right. So y'all work on legally doing number 3 without making up any math. I know. What's funny is my husband and I we do that to each other. Like when the kids are on there, and they're like, "Can we see what you're doing?" I'm like, whatever. Yeah, I know. Are you even trying? Okay. Okay, well, if you're scared it's wrong, maybe have your neighbor check you if you don't want me to come yell at you. Although I'm not going to yell at you. I'll just tell you how disappointed I am. That's a broken heart. Okay. Are you finished? Like, is it separated? Okay. Okay. Yeah. Hey, at least we figured it out. Well, I mean, at least you figured out that what you had wasn't right. That's something, right? What do we think? Yeah, if you want to do some discovery on your table, if you're tired of erasing, that's fine too. Here's one for you if you want it. I don't know where they disappear. You don't have to use it, but it's there if you want it.
Well, I mean, it doesn't have to be by itself, but you have to have dy on one side, dx on the other side, anything that's a y with dy, and anything that's an x with dx. If it's a constant, it could be on either side, but we try and keep it with x if we can. But you can't just subtract it from the denominator.
Oh, it's because I'm just.
Oh, okay, sorry. Anybody have any thoughts? I do. You're kind of going in circles, though, really. But yes, sir. Okay. Only if it was multiplication, not since it's addition. I can't. You can't split a denominator like that. Yeah. So good question. Good catch. All right. So what are we thinking? Not a lot? Well, you're thinking a lot. There's good discussions on why we can and can't do things. Those were good questions. So let's look at this. If I'm going to start by distributing, right? So if I have dy, not distributing, I'm sorry, multiplying both sides by dx, I'm going to get negative 2y plus 3x times dx, right? If we try and do the same thing we did in number 2, we would get 1 over negative 2y plus 3x times dy equals dx. And then we're kind of stuck. We're kind of stuck because there's an x in the denominator over there, and I can't just take it out of the denominator. There's like not a way for me to really do that. If instead I had taken this and distributed it, which I saw some of that, and got dy equals negative 2y dx plus 3x dx. Oh, ran out of room again. Then to get the y over there, I could add that to both sides, but then I'd have a dx over there, and then I couldn't divide it back out, and I'm just causing myself more issues, right? Do you notice what it says, like literally right above number 3 in the... They're not separable. This is not separable.
Why would you say that?
Well, because you have to at least try. And once you might get to a point where you're like, this isn't separable. But you also might get to that point, and then your neighbor be like, yeah, it is, because you can do this, right? So you don't want to think that too quickly. But if you feel like your only option is to add or subtract something over, that's not going to work, because it's either going to have the dx attached to it, and it's just, you're not going to be able to get it back out. Okay. So keep in mind that not everything is separable. Now, the good news is this. We are only going to be working with, well, all of these may not separate, because that's one of the things we're trying to figure out. But the ones that we're going to solve is only the separable ones. But I do want you to continue to work through these now, figure out, separate them, but some of them may not be separable. But before you give up, make sure it's really not separable and that you didn't just miss some sort of math in there. Does that make sense? We good? Okay, so keep going. All right, since you now have trust issues, we will do the next row together. So the first thing I'm going to do is multiply by the dx, so I get dy equals negative 2 dx. And there's not even any x's and y's, so we're done, okay? I mean, the only other thing I could do would be negative 1/2 dy equals dx, but there's no reason to do that. All right, so then let's do this one. First step is to multiply both sides by dx. So dy equals 3x squared y times dx. Don't even have to have parentheses there, right? What would I do next? Divide by y. Good. So I'm really going to make that 1 over y dy, and that equals 3x squared dx. I got all my y's on one side, all my x's on the other. The 3 could be in either place, but again, usually better with the dx. We good on that? All right. Any questions? All right. Let's look at 6. So dy equals 3x squared plus y times dx. All right. Can I divide both sides by what's in parentheses? I mean, I can. Legally, I can. But is that going to help me? No, because that's not going to get my x and y separate. And if I distribute this dx to both of these, then if I move this, if I subtract that over there, then the dx is going to go with it, and that's going to be a problem, right? Aren't we kind of in the same boat we were here? But it worked in number 2, right? So why did it work in number 2 but not in 3 or 6? Yes. Okay, so inside these parentheses I have x and y, where inside of this one I only had y. So that made it okay. That's why I could divide both sides by this one and it'd be good. Since x and y are together here, this one is not separable. Okay. Plus, one of the things that it says up here, after we separate the differentiables, we separate the other variables by multiplication and division, not addition and subtraction. That's not going to work because you would have distributed something in there, right? So everything pretty much has to be done by multiplication and division for it to work, okay? Did we build trust up a little bit again? Maybe a little? Okay, let's just try 7, 8, 9. We'll make sure we can get through those. 7, 8, and 9. You'll be fine. Stop with the drawing and do your work.
I can rewrite this as parentheses.
You can, and it's fine. I don't know that you need to in this situation then. You want to do that when you're taking the derivative or if you're taking the integral. Right now, since we're just separating, I wouldn't, just because it's just going to make it more complicated for you. But yes, you could if you absolutely needed to. Yeah. This looks good. That looks good. Yes. Good. Good. Are y'all threatening each other with this or what? Yeah. Guess what? I know where all y'all live, so. What? All right, 7, 8, and 9. All I did was all I did was multiply both sides by dx right now. On number 7, Jaden had a very good question, and the question was, could I rewrite this as secant of x quantity squared? And the answer is yes. It is the same thing. You don't need to here, though, so I wouldn't necessarily, it wouldn't hurt anything, but we definitely want to do that if we're taking the derivative. And sometimes taking the integral, kind of depending. So don't forget that that is a thing you need to do. So it's very good when that pops in your head. But what would my next step here be? Divide by y. So I'd get 1 over y dy equals secant squared x dx. Got everything separated. We good on that? All right, on number 8, do I need to do anything else? No. I could say 1 over k times dy equals x dx, but it's totally not necessary, so I wouldn't bother doing it, right? On number 9, is there anything else to do? Why are you throwing things? Don't stop throwing air then. All right, are we good with 9 then? We're done? All right, good. Move on to 10, 11, and 12. Y'all are terrible. I just did the first step. I didn't do anything else. All I did was multiply both sides by the denominator. I'm not finished with any of them. I just did that step. I don't want to give away all the answers. Are y'all ready to talk about these 3? All right. So on number 10, is there something else I can do? Yes, I can divide by what? P. So I can put 1 over P dP equals K times dt. Yes? All right. And number 11, is there anything else I can do? No. This is not going to work here, so this is not separable. What do we think about 12? What if I were to tell you it is separable? I mean, using sort of, it's an exponent rule. It's not really the power rule. Give everybody a second to think about it, then I'll let you. Let everybody think about it for a minute. All right, Yair, you want to tell us what has to happen here?
Yeah.
Okay.
So when you multiply a number, the exponents add up.
Uh-huh.
So e to the power of x plus 2y is equal to e to the power of x times e to the power of
dx.
x.
Right? X squared times x to the 5th is x to the 7th because you're adding the exponents, right? So if we have this, we can split them back up like so. Then are we done? No, we got one more step, right? Then we need to divide both sides by e to the 2y. So 1 over e to the 2y dy equals e to the x dx. Right? Make sense? Good deal. Well, I'm sorry. All right. And then I will tell you the last three, all three of them are separable. Go for it. Yeah, go ahead. Do the last three. And they're all separable. That's why I wanted to tell you that before you gave up on something. I know it looks similar to the ones that were not, but make sure you figure out what makes it different than the others. I'm going to go ahead and just write out my first steps here.
Did you say any words though?
Yeah, pay attention to the fractions because a couple of them are different. The process is going to be the same. You just got to make sure that you're multiplying by the correct thing. Yeah, exactly. To be fair, though, she didn't really sound that judgy. It was just a question. Good job. Very good so far. Wait, there's no 4x's. Where are you getting 4x from?
4 plus, oh,
Yeah.
oh, 6 plus 4 from the y.
Yes, you can do that.
And then x times 1 I don't think that's gonna work though. No, actually,
What's the opposite of distributing? If I have, so let's just back up to something that's not so weird. If I have 2 times x minus 7, and I distribute that, and I get 2x minus 14, right? When I go from here to here, what's that called? Can you do that? I know you can't. When you figure out what to do, you're gonna be mad at yourself. Okay, so you got this. Yeah, that's a big fat no, whatever that mess is. But you're trying, so I appreciate that. I already said, y'all don't listen to anything I say. I said all three of them are separable. Listen when I speak. can you change this into something times something? Without, no. What if I had x over 2? I could change that into what times what? Uh-huh. Right? So how can you do that same thing here? You were overthinking it, I promise you. I'm gonna still let you struggle for a minute. That one looks, oh yeah, okay, I'm sorry. I was like, why did this disappear? But yes, that works. Just in what you have, absolutely nothing wrong with what you have, but then when we go to actually work them out, yeah, you would rather have it like 1 over this, but it's fine, it's fine, just as a future thing. Yep, good job. All right, so let's talk through these. On 13, this looks like the ones that are not separable, right? Because we have x and y here, but what can we do? Factor out a GCF. So dy equals y times x minus 1 times dx. So that's going to give me 1 over y dy equals x minus 1 dx. Okay? We good on that one? Yes? Okay. Beautiful. Now here, we had some fancy stuff going on, and then people were throwing shade at the fancy distributing. Do we need to distribute? No, but we were trying something, and that's okay. I can just divide, right? 1 over x plus 2 times dx equals y minus 1 times dy. Yes? We all good with that one? Now this one, some people went down a couple of different roads to end up kind of in the same spot. So first thing is, could I combine these two fractions into one fraction? Yes. Do you have to? No. Either way, it's fine. It doesn't matter either way. But whether I do that or I don't do that, and so I'm going to do it just to show you that you can and there's nothing wrong with it. And sometimes doing those things makes it make more sense to you. Sometimes maybe it doesn't. I don't know. But this is a legal step here. Totally fine. And whether I do this step or not, it is separable because I can either here look at it as factoring out a GCF or just here separating this into 1 over y times x plus 4 dy. That's what I was trying to get you to do. Does that make sense? Okay. And then here, since this is all multiplication, I can divide by the x plus 4. 1 over x plus 4 times dx equals 1 over y times dy. Okay. I also want to make one more note about notation. When I did this here, nope, that's not what I want. When I was here, notice here I did not put parentheses. I can, but I don't have to because basically this is the beginning and this is the end, right? And that is acceptable. But here, if I do not put the parentheses, that's bad because it's not actually in an integral, okay? So those are different things, and here we have to have them. Okay, we okay with that? What questions you got? Think you can separate these now? Yes, so we will start taking it a little bit farther tomorrow. We're going to stop here today.